Here are a few things to note about user-defined functions. One is that you can pass multiple input arguments to a function. Another is that variables that are used within a function, for example, for intermediate calculations, those are called local variables. They're local to the function. And also, a function that returns a value does not normally also print the value. So all the function does is it returns the value, and then in a program, the script is what would do the printing. Let's talk a little bit about what is called scope. The scope of a variable is where the variable is valid. Now, when you create variables in the command window uses a workspace which is called the base workspace. Scripts also use the base workspace. So what that means is that variables that you create in the command window can be used in a script and vice versa. That's a really bad idea, however. But it is important to understand that when you create a variable in a script, and then you get back to the command window, you still have that variable because, again, both the command window and scripts are using a workspace which is called the base workspace. Functions, on the other hand, are completely different. Every function has its own little workspace. So local variables in the function, the input arguments, the output arguments, those are all within the functions workspace, and essentially they only exist while the function is executing. So when the function stops executing, all of that stuff is gone. You don't have access to any of the variables within the function or the input arguments or the output arguments. So again, there's a big difference between scripts and functions in terms of variable scope. Scripts use the base workspace, so all variables that you create within a script are also available in the command window. However, functions do not use the base workspace. Functions use their own workspaces. So any local variable, input argument, output argument, those only exist while the function is executing. And when the function stops executing, you do not have access to any of those things. What we normally called commands are really just shortcut versions of function calls. So when we use the type command or load or save, those are actually really functions. The command form of a function can be used if all of the arguments that are passed to the function are strings and the function is not returning any values. So for example, you can say the name of the function, space, and the string without any quotes around it, and that's equivalent to calling the function and passing to it a string. So for example, when we say something like load and a file name, let's say load file.dat, that's the command form, and that's the same as saying load and then in parentheses the name of the file, file.dat, as a string. So those are completely equivalent. Now an interesting thing is when you load a file, it's going to create a matrix with the same name as the file in either form. Doesn't matter. If you wanted to call it something else, let's say we wanted to call that matrix X instead of file, then we can do that in the functional form. We could say X gets the value of load of file.dat, and it would load it and store it in a matrix variable called X. We could not, however, do that with the command form. So with the functional form we can do that, but with the command form we cannot. Here are some programming style guidelines related to user-defined functions. One is always to put comments in scripts and functions in order to document them. Keep functions short. A rule of thumb is no longer than 1 page in length for a function. Suppress all of the output from assignment statements in both functions and scripts. So basically you want to control the way that output is shown by using formatted output, using fprintf for example. It's very important that functions that return a value do not normally print the value also. So the function simply returns the value. And also important to use array operations in functions so that the input arguments can be arrays, meaning vectors or matrices, and not just scalars.